Hi there, welcome to your lesson on comparing data sets. In many ways, this is the most important lesson so far because we've done some basics in statistics, and now the whole point is how do we use it to make decisions, to learn things about populations. So look at this first picture here. We see a comparison of heights of 7th grade students, of girls and boys, and it looks like what basically you know how to make a box plot now, but when you see a diagram like this, what can you say about the data? What can you say about the population of girls and boys? And in this diagram, we can clearly see the girls have a bigger range or spread of heights because the min is here, the max is here. The boys are here to here. Well, maybe I was wrong in saying that because maybe the spread is the same. One of them just shifted to the right a little bit, right? However, we do know that the boys have a higher median because the median is here. So kind of their middle value is higher. The middle group is higher. The girls are here. We also see the boys have a bigger box. Remember, the box represents from Q1 to Q3. So that means basically from 1/4 of the way into the data, and then here there's 1/4 remaining here. So the middle half of all the boys, the middle 50% of boys have a bigger spread. And we can see this is a smaller box. So the middle 50% of girls have a smaller spread. So the girls, in general, you could say there's a big chunk here. The first 25%, the lowest, the shortest girls, 25%, are really spread out here. But the middle pack of girls are almost all the same height, whereas the middle pack of boys is more spread out. Anyway, you can say a lot just from looking at box plots. Let's take a look at some examples. All right, I'm going to begin with the statement of inquiry because this lesson and where we put everything together really ties to our statement of inquiry. The statement of inquiry says how populations are represented can help to establish underlying relationships and trends in a population. So again, how populations are represented. We're going to take populations, and those can be like groups of things, all right, in statistics, and we represent them in box plots or stem and leaf plots. So how we represent them can help us establish underlying relationships. Basically, how we present data can help us look at what's going on in that data set. What can it tell us about the data set? Basically, we can describe the data set really well using statistics. All right, so let's look at this example again. We have two box plots. These are test scores, first period and second period test scores. So let's say one teacher has two classes and they teach one class first and one second period. And what can we say about this data? Well, first of all, when we're comparing data, we're going to look at two things. Number one, you're going to have to describe the data. So you have to take what you have here and describe, like what's going on. What do you know for sure? So descriptions statistically mean tell us about the center, which we've talked about already, is called central tendency, and tell us how spread out is the data. And this is called dispersion. As you know, the word disperse means to, like, for example, when you say to a crowd, disperse everybody, it means everybody's spread out, right? So dispersion is how spread out it is. Central tendency is what tell us about the center. And in statistics, when we talk about the center, we use mean, median, mode. And when we talk about spread or dispersion, we use range and interquartile range. So those are five right there. 1, 2, 3, 4, 5. Those are five statistics. Actually, they're called descriptive statistics, which is the name of our unit. And those descriptive statistics are used to describe data. So a second step you will have after you've described this data using statistics, you will compare the data. So now that you have some numbers, you can discuss it. And comparing basically means use the descriptive statistics right here to discuss what the data tells us about the two groups, or maybe more than two groups, all right, or about the populations. So let's try an example like that. So here is a problem. It says the back-to-back stem and leaf diagram. So I hope you understand how these work now. There's leaves going this way and leaves going this way. All right, this shows how much time a group of students spent studying mathematics in 1 week. And all times are in minutes, it says. So who studies mathematics more? Just looking at the stem and leaf plot, in general, which group would you say spends more time studying mathematics, girls or boys? Okay, I hope that's pretty evident from the stem and leaf plot. You can see the girls' data is kind of spread out more in this direction, which means they're spending more time because this is like 50 minutes here, 60 minutes. So there's more girls here, whereas the boys, there's a large group on the bottom here, especially 20 minutes, 20 minutes, 25 minutes. So the boys spend less time in general than girls, even though the student that spends the most time is this boy right here, 85 minutes. All right, so first we're going to describe the study times. Again, when we describe, we use descriptive statistics. All right, and then we're going to compare. Once we have those statistics, we can then compare and say things. Like we just made a general conclusion about who studies more, but if we want to really discuss things and be mathematically correct about it, we need the numbers, we need the data, the statistics to back up what we say, right? So we're going to describe with statistics and then compare what's going on here. So let's describe. Again, describe means talk about the center, talk about the spread, central tendency, and dispersion. Center, we use these statistics. Spread, we use these. So please now calculate for the girls, calculate the mean and median. All right, hopefully you got a mean of 35.6, and you got that by adding up all the girls' times. So you added up 10 plus 10 plus 15 plus 20 plus 20 plus 25, and so on. And you divided that by, I think there's 25 girls times that are included here. So you divide by 25. The median, hopefully use the formula we've been talking about, n plus 1 divided by 2. N plus 1, in this case, there's 25 girls here. So we do 25 plus 1, which is 26, divide that by 2, and we get 13. That means the 13th piece of data in this set here. And how would you find that 13th piece? You'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the 13th piece of data. If we wrote these in order, I just went this way, right? And this is the 13th. So 35 is our median. Then I want you to find the IQR, the interquartile range for the girls. So the difference between Q3 and Q1. First, I'll begin just by noting the range. The range is from 10 is the lowest study time for a girl, and 75 is the highest. So the range is 65. And the IQR, Q1 is 25, Q3 is 50. Hopefully you could find those. And then that tells us our IQR is 25. Now let's find for the boys, begin with the mean and median as well. All right, the mean is 26.8. So again, you added up all these study times. For example, there's two boys that had 0, so you did 0 plus 0 plus 10 plus 10 again, plus 10 again, plus 20, plus 20, and so on and so on. Added all those up, divided by 25, because there's also 25 in this data set, and you got 26.8. The median, same as the girls, we did n plus 1 divided by 2. N is how many boys data we have. We have 25 pieces of data here. So you do 25 plus 1, which is 26, divided by 2, 13. So the 13th piece of data in here is the middle value. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the 13th piece of data, and that is 20. So that's our median. All right, now find the range and IQR for the boys as well. The range is 85. It goes from 0 minimum to maximum 85. So that's a range of 85. And the IQR, using a Q1 of 20 and 35. So quartile 1 is 20. It's the halfway point to the median, right? And then Q3 is from the median to the end, the halfway point is 35. So our IQR, or interquartile range, is 15. All right, there's some interesting things we can do with this now. So let's finish this up by, we've described the data, right, using statistics, descriptive statistics. Now we're going to, so I have all the statistics here for us. Now we're going to compare the data. And I'm just going to ask you one question. When you're comparing the data, number one, which group, let's see, remember when we compare, we kind of look at our statistics. So which group, let me see, what was the question I was going to ask you? Yeah, which group in general spends more time studying, and back it up with a statistic. All right, so let's take a look. Um, there's two things you can conclude here. One is looking at the mean. The higher mean and median, both mean and median are higher for the girls. Compare that to this. All right, show that in general girls spend more time studying. All right, so that's the kind of the answer to that question, that the girls spend more time studying. Um, and the mean and median back up that. And you can see it on here as well. We kind of made that conclusion in the beginning just by looking, but here now the numbers back it up. All right, and the second main point, and this one might be a little harder to see, the boys have a higher range but a smaller IQR. So let's take a look. The boys have a range of 85 because again we had from 0 to 85, but their IQR is smaller. Both of these are supposed to show how spread out data is. This number tells us the boys' data is more spread out, but this number tells us the boys' data is less spread out, right? Because this range is greater than that, but this IQR is less than this one. So what's the truth about the boys? Is their data more spread out or less spread out? Well, let's read this here because this is a really important point. The boys have a higher range but smaller IQR. This shows that although their study time is more spread out, when all students are considered, the boys are less spread out in general because they have a low IQR. Okay, so I would argue that the boys have less spread out study times and the girls have more spread out study times. Because basically, if you can ignore this one kind of outlier, we call that an outlier. So this doesn't really match the rest of the data. When you look at the rest of the data, most of the boys are clustered in the middle here, whereas the girls are really spread out here. And the IQR helps us see that a little bit better than the range, because the range includes these crazy end figures, right? And sometimes the end of a data set is not really a good indication of what's really going on. When you want to look at what's going on data, you often look at kind of the middle of the data. And the IQR, as you remember, looks at the middle 50% because it's between Q3 and Q1. So the middle 50% often tells us a lot more about what's really happening in the data. So this IQR for the middle 50% for the girls is 25, but for the boys it's 15. So in the middle, the boys are much tightly more packed because they're only spread out by 15. So that tells us the boys have less spread. All right, I hope all that makes sense. It gives you a little bit more to think about than just simply calculating numbers. And that's kind of what your assessment's going to look like when I see you next time. So consider this video carefully and make sure you understand what's happening. We'll see you soon.